Welcome to our presentation on Gamified AI for Learning, where we explore how game mechanics and artificial intelligence can boost engagement and personalize mastery. In this talk, we'll look at research, practical methods, and design considerations that bridge motivation, adaptive instruction, and classroom realities to transform educational experiences at scale. Here we summarize the core idea. Gamified AI blends game elements with intelligent personalization to improve learner engagement and outcomes. It also notes the range of applications across K-12, higher education, and professional training, while flagging benefits like adaptive learning and challenges such as ethics, scalability, and teacher readiness. Let's unpack how gamification and AI combine to reinvent learning by merging motivation with data-driven personalization. Instead of one-size-fits-all teaching, the fusion supports adaptive instruction, interactive environments, and sustained practice, ultimately improving engagement and retention through targeted motivation and customized learning pathways. This page highlights key research gaps that limit impact and scale, from the lack of unified design frameworks to ethical concerns and mental strain from prolonged use. It also points to underexplored areas like educator integration and long-term retention, underscoring the need for broader, multidisciplinary studies to guide responsible deployment. Here we frame gamified AI as a pathway to personalized, motivating learning, synthesizing theory and practice. It emphasizes accessibility, scalability, and how the paper outlines methods and results across thematic areas, setting the stage for a deeper dive into evidence and design implications that follow. We conducted a systematic search guided by Prisma across major databases to capture original research. The approach combined gamification, AI, and education search terms, excluded prior reviews, and included both technical and pedagogical perspectives to keep the evidence base focused and rigorous. Here we outline the thematic dimensions and inclusion rules that shaped the analysis, such as focusing on general education, language learning, teacher empowerment, adaptive personalization, and domain-specific applications. It also notes empirical inclusion criteria and exclusions to preserve rigor and relevance in the selected studies. In study selection and bias mitigation, we explain how an initial pool of over 1,000 records was screened down to a small set of empirical studies with independent reviewers and adjudication. We also discuss identified biases toward technical studies and steps taken to include gray literature and interdisciplinary sources to broaden evidence. Here we see a clear surge in gamified AI research from 2021 to 2025, with growth moving from foundational concepts toward practical applications and assessments. General education still dominates, but language learning is emerging, signaling a trend of diversification and accelerating interest that merits continued monitoring. Research trends reveal steady publication counts early on, with accelerated growth in 2024-2025, shifting focus from theory to practical methods and assessments. This momentum suggests a growing research community and the need to track new benchmarks and methods as the field moves from exploration to application. In this section, we discuss practical integration strategies combining motivational game elements with AI-driven adaptive content. Examples include AI-tailored challenges, gamified mechanics like badges and levels, and analytics linking behavior and outcomes, all working together to increase engagement and improve learning effectiveness. Here we map general educational applications to AI techniques and gamification approaches, showing how adaptive tutoring, intelligent feedback, practice drills, collaborative learning, engagement, and assessment connect to methods like recommender systems, NLP, reinforcement learning, and badges for mastery. When focusing on language learning, gamified AI accelerates progress by combining NLP, speech recognition, and game mechanics to boost vocabulary, speaking, grammar, and writing. The slide highlights measurable gains, reduced practice friction, and integrated tools that address core acquisition challenges through motivating, personalized practice. The language learning taxonomy maps specific AI technologies to gamification methods across vocabulary, chatbots, speaking, grammar, and writing, illustrating how adaptive repetition, LLM-driven dialogue, ASR feedback, and coaching models pair with points, quests, badges, and peer challenges to drive skill gains. Practical methods for language learning apps include examples like NLP-driven personalized quizzes with leaderboards, storytelling chatbots for semantic practice, real-time pronunciation feedback via speech recognition, puzzle-style grammar exercises, and collaborative writing challenges with AI-mediated peer review to sustain practice and mastery. Here we emphasize teacher co-design as essential for pedagogical fit and classroom relevance, arguing that teacher involvement, adjustable engagement parameters, and deep collaboration produce tailored gamification that aligns AI-driven mechanics with real instructional goals and contexts. The design taxonomy for teachers classifies teacher-centered, student-centered, and system architecture elements to enable customizable gamified AI tools. It highlights interfaces for teacher control, learner UX features, back-end interoperability, and professional development integration as priorities for scalable, context-sensitive deployment. Student-centered design and architecture focus on adaptive systems that adjust difficulty in real time, visualize progress for learners and educators, and use AI recommendations refined by teacher input, creating a dynamic interplay that supports personalization while preserving oversight and improving outcomes. To empower teachers sustainably, we show how shifting educators from passive users to active co-designers through professional development and iterative design builds ownership. It stresses ongoing coaching, teacher-led innovation cycles, and sustainability as essential for long-term gamified AI adoption. This section on adaptive gamification and personalized learning explains how AI customizes game elements to sustain engagement, overcome static gamification limits, and scale personalization while preserving pedagogical goals, showing that dynamic adaptation can improve outcomes through targeted challenges and rewards. The taxonomy of adaptive approaches classifies dimensions like cognitive traits, affective states, behavioral patterns, machine learning, and reinforcement learning, linking each to adaptation strategies such as personalized sequencing, mood-based rewards, nudges, user modeling, and policy learning for long-term engagement. Adaptive approaches explained covers concrete mechanisms, challenge matching to balance skill and flow, emotional monitoring to adjust pacing and hints, behavioral adaptation to suit interaction styles, dynamic game elements for real-time balance, and personalized rewards to motivate diverse learners. Here we introduce AI techniques powering adaptive gamification, showing how machine learning and reinforcement learning personalize recommendations and enable self-optimizing learning pathways, with the result that systems can adapt content, pacing, and incentives based on learner data. Adaptive dimensions drive personalization through cognitive assessment for difficulty tuning, recognition of behavioral patterns to shape incentives, and co-evolving content and mechanics to reduce fatigue and sustain engagement, ultimately integrating assessment, adaptation, behavior, and incentives for continuous improvement. Domain-specific gamified AI tailors designed to fields like medical, engineering, physics, and business by aligning simulations, competitions, and role-play with curriculum goals. The slide stresses embedding domain knowledge and ensuring that mechanics support real educational objectives for effective implementation. The taxonomy of domain-specific applications maps fields to AI technologies, gamification methods, and key innovations, from scenario-based patient simulators in medical education to challenge-based virtual labs in engineering and adaptive problem generators in physics, highlighting domain-tailored outcomes and sources. Medical and surgical education applications use AI-driven virtual patients, NLP assessment, and haptic feedback to create adaptive simulations for clinical decision-making and procedural practice, aiming to improve procedural competence and clinician readiness through realistic, assessed practice environments. In engineering and physics education, generative AI creates adaptive problem scenarios while AI-driven CAD systems provide real-time design feedback for competitions. An integration of domain knowledge with gamified learning helps reinforce theory through hands-on, adaptive practice, and immediate diagnostics. Business and financial education leverage predictive analytics and financial AI to power market simulations and challenge-based trading games that teach portfolio management and strategy, blending theory with realistic, adaptive scenarios to prepare learners for professional decision-making. Design and deployment motifs for domain-specific gamified AI emphasize keeping mechanics tightly linked to real professional tasks, requiring deep domain expertise for successful deployment, using AI for scalable feedback, and designing progressions that mirror career growth and skill ladders. Integrative findings show that gamified AI boosts engagement and personalization, adaptive systems outperform static models, and increased system complexity demands stronger teacher support. The core challenge is balancing usability with deep customization, making teacher-focused, scalable supports a research priority. Here, we advocate integrating AI into gamification frameworks as a core component rather than an add-on, embedding learner modeling, challenge design, and effective data to ensure interdependence between AI and game mechanics for measurable educational impact and evolving frameworks. Practical actions for educators and policymakers include investing in teacher professional development for gamified AI tools, building data infrastructure and analytics capacity, ensuring content flexibility for diverse contexts, prioritizing domain-specific applications, and targeting support for resource-limited environments. Key methodological limitations are summarized here. Many studies have short-term focus, small samples, or limited generalizability, which restricts evidence strength and makes it harder to draw firm conclusions about long-term efficacy, ethics, and scalable deployment across diverse classrooms. Prioritized future research directions call for standardized evaluation frameworks for comparability, hybrid human-AI models combining facilitation with adaptive AI, longitudinal studies on retention, and deeper exploration of privacy, bias, and consent safeguards in AI-driven profiling. Here we frame the balance between motivation, rigor, and equity, arguing we must reconcile enjoyment with academic standards while building scalable frameworks that preserve fairness and teacher autonomy, and use AI's analytic power responsibly to personalize and demonstrate measurable impact. In conclusion, we synthesize the promise and challenges of realizing gamified AI in education. Interactive, adaptive learning is achievable, but long-term evidence, ethical safeguards, and teacher empowerment are essential, and the vision calls for scalable, ethical, and teacher-centered implementations to realize transformative potential.